Okay, welcome back. Let's move to the next question. Okay. Uh, uh, we are discussing the DMB3301 revision session. Okay. Uh, Yesterday, our sir Udek sir conducted a revision session. According to the session, we are discussing the questions related to the revision class. Okay. Now we have discussed all the questions. We have discussed all the questions discussed at the Udak sir's lecture. Okay. Now we are going to discuss about last question. We have discussed all the questions uh, except this question. Okay. Now we are going to discuss about this question. Okay. Let's read the question. A gas whose pressure, volume, and temperature are 275 kilonewton meter minus 275 kilopascal, 0.09 meter cube volume, 185 degrees Celsius temperature. Has its state changed at has its state changed at constant pressure. Its state changed at constant pressure until its temperature becomes 50 degrees Celsius. From 100, the temperature is changing from 185 degrees Celsius to 50 degrees Celsius at constant temperature pressure. How much heat is transferred from the gas? How much heat is transferred from the gas? For example, this the container. They are asking how much energy was transferred to the surrounding or environment, or how much energy lost from the container from the system. They are asking about. They may tell in many ways. Okay, how much heat is transferred from the gas, that's first question, and how much work is done on the gas during the process. Okay, we have then now we have to find the heat transferred, and we have to find the work done on the gas during the process. Take R is equal to 0.29 kilojoule per kilogram Kelvin, uh, 0.29 kilojoule per Kelvin minus kilogram minus 1 Kelvin minus 1 per kilogram per Kelvin. Cp is equal to 1.005 kilojoule per kilogram per Kelvin. Okay. Now we we are in the advanced level chemistry and physics. We studied that R is equal to 8.314. 8.314 எட்டு தசம் 314 8.314 joule mole minus 1 Kelvin minus 1. What is it? But here we already studied that in R is equal to 8.31 for joule mole minus 1 Kelvin minus 1 in advanced level physics and chemistry. Uh, we studied that R is constant. R is constant. R will not change for ideal case. For ideal case, the R is always constant, which is 8.314 joule minus 1 Kelvin minus 1. But here uh, we the question says that R is equal to 0.29 kilojoule per kilogram per Kelvin. What is the here 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 kilojoule mole kilogram minus 1 Kelvin minus 1 joule kilogram minus 1 Kelvin minus 1 here joule mole minus 1 Kelvin minus 1 because this is universal. This is really RU. RU mean universal gas constant. Universal gas constant, which is equal to 8.314 joule minus 1 Kelvin minus 1. But here they are discussing about R, which is here is specific gas constant. Okay, specific, okay, specific gas constant. That is universal gas constant. This is specific gas constant. Constant. Okay. Now this is the small theory. Not only in an early advanced level physics and chemistry, we use PV is equal to nRT. In advanced level chemistry and physics, we use V is equal to nRT. There R is joule mole minus 1 Kelvin minus 1, 8.314. No. Here we use PV is equal to MRT. In physics and chemistry, we use PV is equal to nRT. But in chemistry, but in our thermodynamics and mechanical engineering, in thermodynamics and mechanical engineering, we use PV is equal to MRT. Here, R is joule kilogram minus 1 Kelvin minus 1. Here, M is mass. Therefore, M and kilogram minus 1 will be cancelled. Okay. Here we will use PV is equal to MRT. Don't confuse. Okay. This is the basic. Okay. I think most of the students may confuse that. We already studied that PV is equal to nRT. What is this? PV is equal to MRT. But we have already discussed in our cookie class. Okay, this is not a new thing. We all discussed that. Just recall it. Okay. Now, okay. Let's now they say that what's the initial pressure? I take the P1 okay, initial pressure which is constant, but I take P1. Okay. Oh, no, okay, we take P. Here also P is a constant. P is equal to 275 kilo Pascal. They say that 275 25 okay, 275 kilo Pascal, okay, Newton meter minus 2. Therefore P is equal to 2.75 in scientific notation. Okay, this is notifying using scientific notation. P is equal to 2.75 into 10 to the power 5 Pascal, or to 2.75 bar, because 10 to the power 5. Okay, for extra, now we are discussing about the pressure, volume, temperature in initial stage. Okay, this stage, initial stage. Then we will discuss about final stage. Okay. Okay, now initial volume is they have these are, these are given data. Okay, I didn't calculate anything. They just given data. V1 is equal to 0.09 meter cube. 0.09 meter cube. Okay. Initial temperature theta 1 is equal to 185 degrees Celsius. 185 degrees Celsius. We already know T is equal to theta plus in 273.15. Someone didn't write 515. Some lecturers can may accept, but this is the exact equation. Okay, so theta is T. Someone may write that T is equal to theta plus 273, but this is the very accurate equation. T is equal to theta plus 273.15. Okay, because we can substitute degree Celsius directly to our equations. We already know in our chemistry, in our thermodynamics or in mechanical engineering, we have to convert the degree Celsius temperature to Kelvin temperature. Therefore, T is equal to what is theta? Theta is equal to 185 degrees Celsius. 185 plus 273.15 Kelvin. Kelvin. Therefore, the T1 is equal to 458. If you sum the numbers, we will get finally 458.15. 458.15 Kelvin. Okay. Now T1 is equal to 458.15 Kelvin. Now we are discussing about final stage. Now we are going to discuss about final stage. Okay, at final stage. Final stage. T is equal to constant. Okay, therefore same pressure 0.755. Okay, 2.75 into 10 to the power 5 Pascal. Pascal. Theta 2 is equal to, already they have said that now the temperature is 15 degrees Celsius. Therefore, we have to convert to Kelvin. Therefore, T is equal to theta plus 273.15 Kelvin. T is equal to theta plus 273.15 Kelvin. Therefore, T2 is equal to what is theta? Theta is 15. plus 273. 273.15 Kelvin. Therefore, T2 is finally T2 is equal to 288. 288.15 and 288.15 Kelvin is the final temperature. Now they have given that R is equal to the specific gas constant is equal to 0.25, 0.2529, 0.29 kilojoule kilogram gram per Kelvin. Okay, Cp is equal to Cp is equal to 1.00 kilojoule kilojoule kilogram minus 1 Kelvin minus 1. They are given data. Okay, I Cp is equal to I this kilo no for my easy I write as thousand and thousand and five joule kilogram minus 1 Kelvin minus 1 1005 joule kilogram minus 1 Kelvin minus 1. Mostly I never use kilo to uh, uh, to avoid any mistakes. Okay, sometimes if we use Kelvin we will forget to we will sometimes we will forget the kilo. Therefore, we may make many mistakes. The we just only forget kilo, but the answer may change with 10,000 times. Okay, therefore, okay. Now we have we have noted all the uh, states, pressure, volume, temperature in uh, in notations. Okay. Now let's move to the question. Now the question there are two questions. One question is Q, heat transfer. One question is what is Q, heat transfer. The second question is work done. Okay, now we have to find work done. Therefore, let's move to the question. First we have what we have to find first. First we have to find the mass of the gas. First we have to find the mass of the. We have to find the mass mass of the gas. Okay, mass of the gas. We have to find the mass of the gas. What's the equation? PV is equal to MRT. PV is equal to MRT. P is a pressure, V is volume, M is the mass of the gas, R is the specific gas constant, T is the temperature in Kelvin. Therefore, M is equal to PV by RT. PV by RT. Therefore, M is equal to P. What is P? uh, the, the mass of the gas will not be changed because the gas is inside the container. Therefore, the mass will not be changed. And if we increase the temperature or if we increase the pressure or volume, the mass will not change. Therefore, uh, we use this for EVRT. Here we don't know V2. They said that V1. Initial volume they have mentioned the initial volume. We have to find the final volume. Therefore, we can use only T1 V1 R1 T1. Therefore, R is M is equal to T1 V1 R T1. What is P1? M is equal to P is term 2 point. P is P no. Okay, P 2.75 into 10 to the power 5. 2.75 into 10 to the power 5 Pascal into V1. What is V1? 0.09. No, yes, 0.09 meter cube. 0.09 meter cube divided by in denominator. What is R? What is R? Specific gas constant 0.29 0.29 into 10 to the power 3. 0.29 into 10 to the power 3 joule kilogram minus 1. I convert kilojoule to joule, okay, to minimize the error mistakes. 0.29 into 10 to the power 3 joule kilogram minus 1 Kelvin minus 1 into what is the T1? T1 is 458.15 Kelvin. Therefore, M is equal to if you calculate the equation, finally we will get the answer for M, which is the mass of the gas will be 0.1 0.183 kilogram. 0.183 kilogram. This now we have found the mass of the gas. Oh, why did we find the mass of the gas? Because we have to find the Q, no, heat transfer. What is the equation of Q? Q is equal to mc into delta T. mc into delta T. Therefore, we need M. We have to find the M. Therefore, we have already found the M for first. At first, we found the mass of the gas. They have given the C. Now we know the T1 and T2. Therefore, if we subtract from T2 to T1, we will get delta T. Delta T. Therefore, Q is equal to what is the mass of the gas? M is equal to just now we found 0.0 0 point sorry 0.183 0.186 kilogram. What is the C? C is 1005 joule kilogram minus 1 Kelvin minus 1 joule kilogram minus 1 Kelvin minus 1 into what is delta T? Delta T is T2 minus T1. What is T2? 288 288.15 288.15 minus 458 458.15 Kelvin. Here Kelvin and Kelvin minus 1 will be cancelled. Kilogram and kilogram minus 1 will be cancelled. Therefore, we will get the final answer in joule. The unit of the uh, uh, Q heat transfer is also joule. Therefore, okay, we have verified the units. Okay, if you calculate this equation, you will finally get the answer for Q will be minus 31 point minus 31.78 minus 31.78 kilojoule. This is the final answer. Here, don't forget the minus. Minus. What is the meaning of minus? Because assume that this is the container or system uh, which hold or contain a gas. Now the heat was transferred to the surrounding or environment or heat loss. Heat transferred to the outside. They also asked in question that heat transferred to the heat transferred. Okay, therefore that is the meaning. Now we have we have gotten the minus. Therefore, our answer is correct. Because you how we verify it you using this minus notation. They asked the question how the heat transfer. We also in our equation, our in final answer also we get this. We got this minus sign. Positive sign means uh, energy if the energy comes to the system or container, that is that time Q plus. Here energy transferred to the surrounding or environment, heat loss. Therefore Q minus. Okay, therefore the heat transferred, the first question is heat transferred. Therefore please write that uh, uh, heat transferred heat transferred to uh, the heat transferred is equal to 31 point. The heat transferred is equal to 31 point. Q is equal to minus 31.78 kilojoule. But when we told in practically when we talk we don't say about minus. Therefore we have to say that in statement say that the heat transferred is uh, the heat transfer is 31.75 2.78 kilojoule. We don't mention minus when we say in words. Okay, mathematical notation only we use minus. Okay, it's very simple thing. Minus sign indicates that the heat has been transferred from the gas. The heat has been transferred from the gas. The heat was transferred from gas to environment. That's very simple. Now we have we have found the Q. Okay, Q found. Now what is we have to found? We have to found W. We didn't find. We have to found W. W. Here, uh, P is how to find work done. We have to find work done. How to find this? Discuss about. Uh, you already know this equation. PV is equal to MRT. We already used this equation at our question now. PV is equal to MRT. Here M is constant. R is also always constant. M is also constant. Mass of the gas is constant. Specific gas constant R is also always constant, which is 0.29 something. P is also constant. They have already mentioned that. Okay, they have already mentioned P is constant. Therefore, V by D is constant. All are constant. Therefore, we already discussed it. We don't need to dive very deeply. We already know. Therefore, V by D is equal to constant. Constant. Therefore, if V by constant, okay, constant, okay. Therefore, if the V by D is constant, we can write that we have already studied in advanced level chemistry. V1 by T1 is equal to V2 by T2. Now we have to find the V2. We know V1, T1, T2, but we need to find V2 to find the work done. Therefore, V2 is equal to T2 by T1. I multiply by T2 uh, both sides. Okay. Therefore, T2 and T2 will be cancelled. T2 and T2 will be cancelled. Therefore, V2 is equal to T2 by T1 into V1. T2 by T1 into V1. T2 by T1 into V1. Therefore, V2 is equal to what is T2? T2 is equal to 288. 288.15 Kelvin. Kelvin. What is T1? 458. 458.15 Kelvin. What is the V1? 0.09. 0.09 meter cube. Okay, 0.09 meter cube. Therefore, the final answer will be V2 is equal to 0.05. Okay, 0. Sorry, V2 is equal to 0.05 6605 6605 meter cube is the V2. The last, the final volume of the gas. Oh, the final volume of the container. Okay, all are same. We already studied in advanced level. No. Now we have to find the work done. Now we have to find the work done. The final question. Uh, how to find the work done? What is the equation? Here we have to use the special equation. Here, uh, here they already said that T is constant. T is constant. No, they already mentioned that P is constant. Therefore, that P is constant. When P is constant, there is equation to find this. Okay, that is the work done W is equal to P into V2 minus V1. V2 minus V1. That, if the P is constant, we can use this equation to find the work done. W is equal to P into V2 minus V1. P into V2 minus V1. In our early cooking classes, we already discussed that PV is we have proved that in our early cooking classes we already discussed and proved that PV is the unit of PV is joule. This is the energy equation of energy. No, therefore W is equal to P into V2 minus V1. We know the P 2.75. 2.75 into 10 to the power 5 Pascal into what is V2 Pascal. Okay, W, sorry, W is equal to 2.75 into 75 into 10 to the power 3 Newton meter minus 2. Uh, for one reason, uh, I write Newton meter minus 2. Then what is the V2? V2 minus V1. What is V2? We just now we found that V2 is equal to 0.057 approximately 0.057 meter cube meter cube 0.057 meter cube. What is V1? V1 is 0.09 0.099 meter cube. Therefore, if you calculate this equation, you will finally get the answer for W will be minus, because the initial volume is 0. Yes, the initial volume this is 0.0 approximately 0.05 0.05 this is 0.09, therefore minus. Therefore, the work done will be minus 9.075 9.075 kilojoule. The final answer, the work done will be W is equal to W is equal to minus 9.07 kilojoule. Okay. First, now how much heat is transferred from the, okay, now you have found the heat transfer. Then how much work is done on the gas during the process? Okay, the W is minus, no, W is minus. You have found how much work is done on the gas. Okay. Yeah. Now, what is the meaning of W is minus? What is the meaning of negative in the at the work done? At the work done, the W was minus sign, no, with minus sign. What is the reason? Was the gas we use this we use the equations for gas. We use these equations for gas, but here gas didn't do any work. The gas didn't do any work. Therefore, but if the gas did any work, the W work done will be plus. But here the gas didn't any work. Uh, uh, we we done some work to the gas. Gas didn't do anything. Therefore, W is minus. If the gas did anything, the sign will be plus. Okay, here gas didn't do anything. The is how much work is done on the gas? Okay, but on the gas. Therefore, on the gas. If the gas do anything, the W is plus. Here the gas work is done on the gas. Therefore, W will be minus. If you get the answer for plus, please check your answer, because your answer is wrong, because it must be in minus. Okay. Now we have discussed all the questions our Mr. Uday Kumar sir mentioned in our yesterday yesterday lecture, tuition lecture for the DMB3301. Okay, 01. Yeah. Now, okay. Now we have all discussed all the questions with very very clearly with answers. Now, we have completed this chapter. Okay, these classes. In next video we can meet. Okay, bye. Congratulations for your exam. Okay, bye.